Sometimes you may be asked to take I and to raise it to a really big power. So as you see on this slide here, I have like I to the 40th power. We're multiplying 40 i's together, or I to the 52nd, or something like that. And the key to doing these problems is this question I wrote in red. How many I squareds can I fit into that? We know what I squared is. I squared equals -1. That better be like in your head. You better know that backwards and forwards by now. I squared equals -1. So I just want to know how many -1s, how many I squareds can I actually fit in this? So if you have I to the 40th power, you can think about that as I squared times I squared times I squared times I squared 20 times written out. Because if you have 2 here, 2 here, 2 here, and you do that 20 times, so 20 times, you're going to have 40 i's altogether. Well, if you have 20 of those, each of those is a -1. So that's really -1 times -1, because I squared is -1, times -1, 20 times. So there's really 20 -1s, which I can also write as -1 to the 20th power. Well, -1 to the 20th power is just +1. If you multiply 20 -1s together, you just get 1 as your answer. So this I to the 40th power right here is really just equal to +1. Because if you do -1 to the 20th power, that's what you get. So sometimes when you raise I to a power, you get 1 as your answer, a regular real number. Let's do it again on this second one here. This one's going to be I squared times I squared. We're going to do that. 52 divided by 2 is 26 times. Wait. Yes. So 26 times we're multiplying out our I. Let me actually change this. I apologize, guys. I'm going to change this to I to the 50th power, just so I get a different sort of situation here. So this is going to be I to the 50th. If I do that, I to the 50th, I'm going to have this written out 25 times. So if I have 25 I squareds lined up, that means I get -1 times -1 times -1 times -1, 25 times. Well, if you multiply 25 -1s together, you're going to get -1 for your answer. So sometimes when you raise I to a power, you're going to get -1. And that's why I changed the problem. I to the 52nd actually would have been +1 as well. So this time we got a -1 when we raised I to a power. On our third try here, we have I to the 71st power. So again, we're going to write this out as I squared times I squared times I squared. We're going to do that 35 times. If we do it 35 times, that is going to make I to the 70th power. So what actually happens, if that's only 70, we actually have one more I, just plain old I, sitting right there. Nothing we can do with that. He's just sitting on the end. He doesn't get a squared because we have 71 altogether. Well, my 35 I squareds really means -1 35 times being multiplied. And then there's that leftover I, that guy who didn't have a partner. He's still sitting there on the end as well. Well, -1 to the 35th power is -1, so my answer is -1I. So, I had I to the 71st power. That was actually equal to -1 times I. No more exponent on it, just -1I. And I have one more problem on here. On this one, again, I'm going to write it out as I squared times I squared. I can do that 50 times, and there's going to be one I left over. So I really have -1 to the 50th power, and there's an extra I. Well, -1 to the 50th is just 1. So what I get for my answer is just 1I, or I. Same thing. So this guy was actually the same thing as I. So if you take I and you raise it to a really big power, these 4 problems are the only possibilities. You can either get 1, -1, -1I, or just I. And it's just a matter of writing out a bunch of I squareds to see which one you'll end up with.